Hello students, welcome to the EPG Pathshala. My name is Dr. Rajeshwari Sinha and in today's lecture we are going to learn about the measures of central tendency. This is an important concept in biostatistics. It helps designate a particular value which can represent an entire data set. Let us see what objectives we are going to address in this lecture. We are going to understand what is central tendency and what are the various measures of central tendency. We are also going to look in detail what is mean, median and mode, each with some examples. Finally, we will look at the symmetric and asymmetric distribution of data. We hope you have an enjoyable time listening to this lecture. What is central tendency? The property of a given set of data to tend to remain clustered about a center point is called the central tendency. Measures of central tendency has the following properties. A single value which can be used to describe a given set of data is referred to as the central tendency. The value is obtained by identifying the position which is central within the given set of data. It is also known as a measure of central location. The mean, median and mode are three types of measures of central tendency. The mean. Mean is the average of a set of data or values. Sum of all the data values divided by the total number of values in the data set gives the mean. It is denoted by x bar generally. If there are n values in the data set ranging from x1, x2 till xn, the mean is obtained by the formula given below, where n is the total number of values in the data set. It is the most popularly used measure of central tendency. Now let us see the advantages and limitations of mean as a measure of central tendency. The advantage is that it is applicable to both discrete and continuous data, although most often with continuous data. The limitation is for categorical data, mean cannot be calculated and outliers and skewed distributions often influence the mean value. Here we look at an example of calculating mean. For example, in the given following data set, the total number of values in the data set is 11. Therefore, the mean is sum of all the values divided by 11. Median. The middle score in a given data set, given the values are arranged in ascending or descending order, gives the median. 50% of observations remain on either side of the median. When a data distribution has odd number of values, the middle value forms the median value. When a data distribution has even number of values, there is no single middle value. There are in fact two middle values. In this case, the median value is obtained by averaging the two middle values. Now let us look at the advantages and disadvantages associated with median as a measure of central tendency. Outliers and skewed data less affect the median as compared to the mean. This is one of the advantages of median over mean. In terms of limitations, the median cannot be identified for categorical data. This is because the data cannot be ordered or arranged in a specific sequence. Here we look at an example of how to calculate median. In the given data set below, we have a number of values which are arranged in an ascending order. Also note that there are odd number of entries, that is 11 entries. Therefore, the median is the middle value, which is 37. In this next set of example, we will see what happens when there are even number of entries. When the data set has even number of entries, it can be again arranged in ascending order. Now we see that there are 12 entries and 2 middle values. Therefore, the median is calculated as sum of the two middle values divided by 2, which is 26.5 in this case. Mode. The most frequently occurring value in a given data set gives the mode. The advantage of mode is that it is applicable to both numerical and non-numerical data set. Let us look at the limitations now. In some cases, the mode does not very well reflect the center of the distribution. Sometimes a given data set can have more than one mode. This is because a single value to describe the central tendency of data distribution cannot be identified. Sometimes where the data are continuous and all the values in data set are different, there may be no mode at all. In such cases, the mean or median is to be used as the measure of central tendency. Let us look at an example of calculation of mode. In the following data set, we calculate the number of times each value has occurred, which is shown in the table alongside. The number of times each number has occurred is represented as frequency. We see that the number 44 has occurred the maximum number of times, and therefore the mode in this data set is 44. Students, we have now come midway into this lecture. We have looked at three important measures of central tendency, namely mean, median and mode, along with certain examples. In the next section, we are going to understand the concept of skewness. Skewness arises when data is asymmetric in nature. Let us see how the measures of central tendency vary as the data moves from being completely symmetric to asymmetric. Skewness. Skewness reflects the extent of asymmetry in a given data distribution. Comparison of the mean, median and mode can provide information about skewness. For a symmetrical distribution, the mean is equals to median is equals to mode. However, the mean is widely preferred as a measure of central tendency in a symmetrical distribution. For a skewed distribution or asymmetrical distribution, the median is more appropriately used as a measure of central tendency. This is because median is not affected by extreme values. In the skewed data distribution, the mean does not usually form the middle of the distribution and remains generally pulled in the direction of the tails. Symmetric distribution. In this kind of distribution, data is normally distributed or symmetrically distributed. We have the mean equal to median equal to mode. The distribution is mound shaped and no skewness is observed. Figure 1 shows symmetrical distribution of data. Left skewed or negatively skewed distribution. In this kind of distribution, data is asymmetrically distributed, mean less than median less than mode. The tail on the left side of the distribution is longer than the right side. In the negatively skewed distribution, mean remains pulled towards the left side of the distribution, which means to the left of the median. Right skewed or positively skewed distribution. Here, the data is again asymmetrically distributed. The tail on the right side is longer than the tail on the left side of the distribution. Mean is greater than median, which is again greater than mode. In a positively skewed distribution, mean remains pulled towards the right tail of the distribution and therefore mean lies to the right of the distribution. We have now come to the end of this lecture. Thank you for being there with us, but before we end, let us summarize what we have learnt in this lecture briefly. A single value which can be used to describe a given set of data is referred to as the measure of central tendency. The mean, median and mode are three types of measures of central tendency. The mean is the average of a given set of data or values. The median is the middle score in a given data set, given the values are arranged in an ascending or descending order. Mode, on the other hand, is the most frequently occurring value in a given data set. Skewness reflects the extent of asymmetry in a given data distribution. For a symmetrical distribution, the mean equals the median, which again equals the mode. The mean is the widely preferred measure of central tendency in case of a symmetrical distribution. On the other hand, for an asymmetrical distribution, median is more appropriately used as a measure of central tendency. This is because the median is not affected by extreme values. For negatively skewed distribution, mean is less than median is less than mode, while for a positively skewed distribution, mean is larger than median is again larger than mode. Thank you for watching this lecture on measures of central tendency.